Welcome back to part 2 of your lesson today. We are going to start to learn how to design something for our biomimicry engineers. The engineering firm luckily sent us a few guidelines that will help us when we make our plan. They want these designs to follow their guidelines. When engineers make designs, they think about how their designs will work specifically to solve problems. Here are their 2 guidelines. First, your design should use ideas from one of the adaptive traits of the grove snail. And if you need a reminder on what those are, it's coming up next. Also, your design should help solve a problem. So now is our chance to brainstorm some ideas for how the adaptive traits of a grove snail can inspire designs that will help solve problems. Here on the slide, you'll notice a grid that will help us. In the first column at the very top, it says adaptive trait of grove snails. Shell color that blends in with the environment. We know that if it blends in with the environment, it's less likely that the predator will see them, so they are more likely to survive. And a strong shell means it's harder to crush and it's harder for those song thrushes to eat them. Then in the middle column, it says, why are grove snails with this trait more likely to survive in their environment? So a grove snail with their shell color that blends in is more likely because of what I have written right there in orange. It's easier for them to avoid being seen by a predator. So now, here is an example of how color can help solve a problem. Some people want to leave an extra house key outside, in a yard or on a porch, but they don't want everyone to see it. So, if you can design something that blends in with the environment to help hide that key, then maybe it's just like the adaptive trait of our banded-shelled snails. So if the extra key was in a container that blended in, that would solve the problem. No one would be able to see the key, but the person would know it was there. So we can add that in the third column, how could this trait help solve a problem? It could help hide something important like keys. How else could something that blends in with the environment help solve a problem? This is where I want you to pause the video and be creative. That's an example that I gave you, but I bet you can come up with so many of your own ideas. Think about things that blend in or things that camouflage. How could that help solve some problems? Pause right here and write them down because you're going to want these in a few minutes. Now we're going to think about the trait for a strong shell. Why are snails with a trait for stronger shells more likely to survive in an environment? Remember what's important, like I mentioned, they're more protected from being crushed. So the stronger the shell, the more protection they have. So we could add in, they're more protected from being crushed. Now, how could that help solve a problem? So here's an example of how strength can help solve a problem. When I pack tortilla chips in my lunch bag and I put them in my backpack with my books, sometimes the chips get crushed. But if the chips were in a container that protects them from being crushed, that would solve the problem. So I wrote in here, could help protect things that break easily, like tortilla chips. Now that's just one example. But I want you to spend some time now thinking, how could the trait for shell strength help solve a problem? What other things might be important to protect? So what are things that break easily that you might want to protect that we could design to help those things or to protect those things? Remember to think creatively and come up with ideas that are different than the ones that I showed you. So pause here and record all the ideas you have. How can you design something that blends in with an environment that would help solve a problem, or something that's strong or protects something that's weak that helps solve a problem? When you press play again, we will finish out our lesson for today, including time with your design. So the chart we just made includes a few of your design ideas inspired by the 2 adaptive traits of the grove snails. You might have your own ideas, which I think is great. Right now, we're gonna spend some time, and first you're gonna think about the problem that your design can solve and how it uses ideas from the grove snail traits. And then you will design or draw your designs. So if you have your own ideas, that's a great way to do it. I'm gonna show you a template here if it helps you to write it down for your notes, but definitely be writing these down because we're all gonna wanna see them. It says here, choose a problem that you will try to solve with your design. So that's where I want you to spend a lot of your thinking time. What's a problem out in the world that you wanna solve? What will your problem try to solve, and how can the adaptive traits of a grove snail, the hard, stronger shell, and the idea that the shell blends in with the environment, how can those 2 things help you with your design? So remember, your design should use ideas from one of the grove snail's adapted traits and help solve a problem. Now is your time to draw. This might be your longest pause yet, but you're gonna press pause here and make your drawing. I'm gonna draw one too, and then I'll see you when you hit play again. So keep working, or now we'll work on your design, and as you draw, think about how your design shows that you are meeting the design guidelines. How does it solve a problem, and how does it use one of the adaptive traits from the grove snail? If you need a little bigger space, this is one for you. If you haven't pressed pause yet, now is your time because we will move on after this. So now, if you've already drawn your design, hopefully, you have it with you right in front of you. You can take notes on it and write around it if you want using labels, but we're gonna check to see if your design meets the guidelines. So as biomimicry engineers, you need to think about what your designs should be like and how they should work. You also need to make sure that your designs are meeting the design guidelines. So we're gonna stop for a moment and see if we're meeting the guidelines for our design. Does your design use ideas from one of the grove snail's adaptive traits? So does it have to do with blending in, or does it have to do with strength or how thick or strong something is? And the second one for evaluating our design, does your design help solve a problem? If not, that's okay. You can pause here and change your design so that it meets the guidelines. Now, as biomimicry engineers, sharing your designs with other engineers can help improve your designs. You might think of something that you want to change to make your design be more successful, and that's a great thing to do. It's just like editing when you do that in writing. You're going to use these planning sheets here to share. Now this is going to be a little bit different because of how we're learning these days, and that's okay. You can always practice sharing ideas out loud, even if you're just talking to the screen that's on pause. You can talk to your finger over here, you can find a plant near you, you can pretend there's something on your shoulder, whatever you want to do, so that you're practicing what it is like to talk about your ideas out loud. If you can also try to share this idea out loud with your teacher and then ask some questions about how you can better revise your designs based on new ideas that your teacher or someone in your house might help you with. What's important to remember is when you're sharing and when you're listening. So if you're sharing, you want to talk about your design and explain what it's supposed to do. You also want to explain how you used ideas about the grove snail traits in your designs. Then you'll listen and you'll answer questions as people ask them. If you're listening to someone else share their design, then you have a chance to ask some questions. So you could ask them, what problem does your design solve? What do you think will work well when you actually create it and why? And what might not work well and why? As you're doing this, make sure you take notes for ways you can improve, change, or edit your design. Hopefully you'll get some new ideas from this experience and you can take those and spend some time revising your designs. After this, you'll spend some time to continue drawing and make any changes needed. In the next lesson, you will revise them one final time. So remember right now when you're making this, you need to meet your 2 guidelines and you need to write some notes on there. How can I make this design better? So if you want, think about it tonight and maybe tomorrow you can look back with fresh eyes and say, how could I change this? What else could I add? You can try to share with your teacher if possible, if you meet with them this week, or share with someone in your household and say, hey, I'm making this design. I want to show it to you and I would like for you to ask me some questions so that I can make it better. You guys have done an excellent job today. Here is one reflection question. Now remember, your design is your priority, but if you have time, this is a lesson reflection for you. Daily written reflection. Look at the structure of an octopus's arms. Based on the structure of the arms, what might be the function of the octopus arms? So because of the way that they're shaped and all those pieces, what do you think they're used for? In other words, what is the function? For this, you can definitely draw or write your answer. What do you think an octopus needs those arms for? You guys did great today. We will see you next time to close out all of Chapter 2 in our next lesson. Can't wait to see what you design.